Hello YouTube, Nodvic here. I know it's been a long time since I've uploaded anything not worth talking about, but felt like making a quick video here because I just had a discussion, had to explain a basic risk-benefit analysis situation to someone, and show them why the pass down orders was correct. Uh, they work in a call center with 58 agents or so on shift right now, including themselves. But a scheduled maintenance from before shift extended into shift, so several people who were logged in and up and going while there's still maintenance going on. As a result, certain files and cookies and whatnot were cached, being from pre and during maintenance, causing errors and problems. And clearing cache should work to fix it. Rebooting will work to fix it. And so they were told to clear cache as before trying to reboot, and for some reason this didn't make sense to them, and they thought everybody should just go ahead and reboot. So I had to explain the basic math there, and I thought to myself that it seemed kind of obvious, but apparently it's not, so I explained it to them. Thought I'd throw together a little video here. Now 58 agents, we're just going to call that 60 to make the math easier. Although I'm using a spreadsheet, it'll do the math for me, but basically the amount of time possibly saved is worth the risk of the amount of extra time lost by doing the clear cache attempt. So we're going to do a little spreadsheet here, and we're going to go clear cache success needs reboot, and get 60 people here. Boop. And we're going to go sum b2 b61, and we'll go sum c2 c61. So now the clear cache should work for like 90% of people, but to put it in favor of the person that didn't think it was worth it, we're going to drop that to like 75%, right? So we're going to go 60 times 0.75, I need to put an equals there, is about 45 people succeeding and about 15 people failing. So we're going to go to 15 there, go 0, 0, 1, come on, there we go. So we got that. So we got 45 people succeeding, 15 people needing reboot. But we also want to know what the total possible time is. So reboot takes approximately 2 minutes, clear cache takes approximately 15 seconds. Could take a little less, could take a little more, but we're just going to go with that to make the math easier again. So we're doing basic risk-benefit analysis, we're not going super advanced. So we got time saved, which means we're going to be saving about 1:45 or 105 seconds. Per person that the clear cache works for. So we're going to go B62 times 105 seconds. That's our time saved. We got extra time lost, meaning the 2 minutes that was guaranteed if we do reboots only, plus the clear cache attempt is another 15 seconds each. So we're going to take the total people that had to reboot even though they tried clearing cache, multiply that by 15 for the excess time lost. So we're going to go 15 times C62. So we got extra time lost of 225 in the case of 75% success rate. So our total possible time lost if we do reboots only, that's out of 60 people, equals 60 times 2 minutes, which is 120 seconds. Total possible time lost of 7,200 seconds. Total possible time saved is 1:45 or 105 seconds each for 60 people. So we're going to go equals 105 times 60. So that's total possible time saved by clearing cache, 6,300 seconds. Now, what we want to do, I lost my place in my brain. What we want to do is like you should already be able to look at those numbers and see that the possibility of saving 7,200 seconds and the remote possibility of losing 6,300 seconds, most likely it'll be somewhere in between. Definitely worth it, because you got a 1 in, what, 3,600 chance of all of them needing a reboot, because 60 times 60 times 1. Anyway, so right now, if we were to go with the current, we save 4725 and lose 225. So we go equals B63 minus C63. This is total time saved, including the time lost from the people that still needed a reboot. So we got equals floor 4,500. We're actually going to take the D63 divided by 60, and that's 75. And we want to go. We want to concatenate these. So we're going to concat comma colon comma D63 divided by 60 minus floor D63 divided by 60, and then we want to multiply all that by 60 because it's going to give us our seconds remainder from the minutes. So we got 75 minutes and 0 seconds saved in man hours. That's total time saved across all the people added together. I guess the reason that works, if we take just this here, we go. Let's get a different number, so that doesn't end in a nice round number. So let's say 63:42, right? We got 63 minutes and 42 seconds. So we got calc. Nope, calc's not over there. It's over here. 63 times 60 plus 42. That's 38:22 seconds. So let's put 3822. Dang, auto formatting. 3822. Right. So we have 3822 divided by 60 gives us 63.7. If we go floor 3822 divided by 60, we get the 63. If we go 3822 divided by 60 minus floor 3822 divided by 60, we should get the 0.7. And then we get 0.7 times 60, oops, equals 0.7 times 60. Sometimes I hate LibreOffice. It's not as quick as Microsoft Office to just know what you're doing. We get the 42 seconds, right? So what we should get is 63 minutes and 42 seconds when we do the whole thing here. So we go 3822 divided by 60 minus floor 3822 divided by 60. And then we go times 60. We get the 42 seconds. So let's add the concat. Do that. Let's pop back over here, and we get the floor 3822 divided by 60, comma, and we get the 63 colon 42. This is the 0.002 is just a normal problem with floating points math with computers. You can just truncate that or ignore that. We can even just drop it by going round comma 2. Guess not. That needs to go on the subtraction here. Round blah comma 2. There you go, 63.42, and that's what we expected to get, and that's all that this is doing. So if we have a 75% success rate, we save that much. If we were to say have a let's say we have a 50%, so let's grab down to 30 here. And we'll go 0, which means we want these to ones, we still save 2,700 seconds, which is of course 45 minutes. So even with a 50% success rate, we're saving 45 minutes. Even if we go to a 75% success or 75% fail rate, right? So that's 60 minus 16 is 50 minus 6 is 44. So we go down to 44 here. Let's zero those out, and we'll go. We still save 10,000 seconds of man hours. So the only the farther you get, the closer you get to actually losing time, but the chances of getting more and more failures is less and less and less and less. So basic risk benefit analysis says everybody try to clear cache first. If that doesn't work, reboot. If you just reboot, you are guaranteed to lose a lot of time. If you clear cache first and then reboot, you still have a tiny chance of losing a lot of time in total across all the agents. Just clear cache. It's basic math, it's basic RBA, but people don't really think in those terms. So I felt like making this video just to give a real world example for anyone doing risk benefit analysis. All this stuff is pretty easy to do in your head. If you're taking classes on business or doing risk benefit analysis professionally, you're not going to need a spreadsheet for something this simple. It should, be pretty obvious, but there you have it. And that